So yesterday we discussed some basic things about sound. ठीक है, आज ये first part complete करते हैं. There are certain formulae which you need to note down. मैंने कल waves के characteristics के बारे में बताया था तुमको. Now there are some parameters which are related to the wave, and those are, as I listed yesterday, frequency, ठीक है, time period, wavelength, amplitude, और एक है wave velocity, speed of sound. Wave velocity is the speed of sound wave or speed of any wave, wave velocity. ठीक है, so these are the quantities which we are going to deal with: frequency, time period, wavelength, amplitude and wave velocity. इसमें से कुछ फॉर्मूले हैं. सबसे पहले फॉर्मूला हम लोग इन दोनों को रिलेट कर लेते हैं, फ्रीक्वेंसी और टाइम पीरियड को. फ्रीक्वेंसी इज द रेसिप्रोकल ऑफ टाइम पीरियड. Frequency is the reciprocal of time period and time period is the reciprocal of frequency. ये तुम्हें पता ही होगा. ये हो गया फर्स्ट रिलेशनशिप. देन वेव वेलोसिटी. वेलोसिटी क्या होता है? डिस्प्लेसमेंट अपॉन टाइम. ठीक है, यहां पे जो डिस्प्लेसमेंट है ना, दैट इज वेवलेंथ. डिस्प्लेसमेंट मतलब वेवलेंथ. ठीक है, अपॉन टाइम. टाइम क्या है? टाइम पीरियड. सो दिस इज वन ऑफ द मोस्ट इंपॉर्टेंट फॉर्मूला. v इज इक्वल टू लैम्बडा बाई टी. न्यूमेरिकल्स में बहुत पूछा जाएगा. v इज इक्वल टू लैम्बडा बाई टी. अच्छा, डू यू नो दैट 1 by t is f? yes, 1 by t is f, we know that. ठीक है, सो क्या मैं इसको लिख सकता हूं लैम्बडा टाइम्स 1 by t, दैट मीन्स लैम्बडा टाइम्स f. सो v का ये दूसरा फॉर्मूला हो गया. द सेकेंड फॉर्मूला फॉर v. v इज इक्वल टू लैम्बडा टाइम्स f. v is equal to lambda times f. Frequency times wavelength is wave velocity. Wavelength divided by time period is also wave velocity. और ये दोनों फॉर्मूले तुम्हारे न्यूमेरिकल्स में बहुत ज्यादा यूज होंगे. सो कीप देम इन माइंड. फर्स्ट पार्ट के न्यूमेरिकल्स. सेकेंड और थर्ड पार्ट में तो न्यूमेरिकल्स नहीं है, सो यू डोंट हैव टू बॉदर. इनफैक्ट जब तुमने इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम किया था तो उसमें भी ये फॉर्मूला था, सिर्फ उसमें v की जगह पे c था. c क्या है? स्पीड ऑफ लाइट इन वैक्यूम और एयर. स्पीड ऑफ एनी इलेक्ट्रोमैग्नेटिक वेव इन वैक्यूम और एयर इज c. c इज 3 times 10 to the power 8. तो c इज इक्वल टू एफ लैम्बडा फॉर्मूला हमने यूज किया हुआ है. ये वही फॉर्मूला है, बट साउंड के टर्म्स में थोड़ा सा अलग से लिखा है हमने, v लिखा. There are certain parts which I feel that they will not be of any use when we are doing this part or this particular topic or this chapter. So I'm not going to talk about them. जैसे कि यहाँ पे वो लोगों ने gamma दिया है. Gamma is ratios of two specific heats. Specific heat तुमने नहीं पढ़ा है अभी तक ना, क्लास 10th में तुम कभी पढ़ोगे उसको. स्पेसिफिक हीट कैपेसिटी ऑफ वाटर के बारे में तुम पढ़ोगे कैलोरीमेट्री में, जिसका इससे कोई लेना देना नहीं. दिस गैमा विल बी टॉट टू यू इन क्लास 11th. ठीक है, सो इसके बारे में जो भी इंफॉर्मेशन है आई कैन रीड इट आउट फॉर यू, बट देन यू विल आस्क मी सर व्हाट इज गैमा. आई कैन नॉट एक्सप्लेन यू बिकॉज फॉर दैट आई हैव टू एक्सप्लेन यू द होल थर्मोडायनेमिक्स. वी आर नॉट लर्निंग अबाउट थर्मोडायनेमिक्स राइट नाउ, सो आई एम नॉट गोइंग टू गो डीपर हियर. अच्छा, Can you tell me, can sound travel through solids? Can sound travel through a metallic string? Right? Can you tell me an instrument which has metallic strings? Guitar. Do you agree with me when I say that whenever guitar strings are attached in the guitar, they are given a tension. They are tightened, so they are tensed. है ना, उनमें एक टेंशन होता है, and the sound which produces when we strike the strings, it is somehow related to the tension which is in the string. If the tension is less, the sound will be less. Intensity of sound will be less. If the tension is high, intensity will increase. So somehow in stretched strings, sound depends on the tension of the string. यहाँ पे एक फॉर्मूला दिया है, the speed v of a transverse wave in a stretched string. Why in a stretched string a transverse wave is produced? Can anyone say that? पहले तो मुझे बताओ कि वेरी गुड, यू आर राइट, सॉलिड्स एंड लिक्विड सरफेसेस, क्या इनमें साउंड ट्रैवल कर सकता है? यस, इट ऑलवेज ट्रैवल्स इन द फॉर्म ऑफ ट्रांसवर्स वेव्स, बट इनसाइड द लिक्विड एंड इन द एयर sound travels in the form of longitudinal waves. If you vibrate a string, you can see the string is making waves like transverse waves. So that's why they say that speed v of a transverse wave in a stretched string depends on tension T and the mass per unit length of the string. What do you mean by mass per unit length? Mass per unit length is the thickness. जितनी ज़्यादा string है, थिकनेस है स्ट्रिंग की, उसके ऊपर भी वो स्पीड ऑफ द साउंड, स्पीड ऑफ द वेव प्रोड्यूस्ड डिपेंड करेगा, और उनका जो रिलेशनशिप है डायरेक्टली विदाउट एनी डेरिवेशन दे हैव गिवन, v इज इक्वल टू अंडर रूट ऑफ t बाय n. What is t? Tension in the string. So speed is directly proportional to the square root of tension, and speed is inversely proportional to the square root of the mass per unit length. मतलब जितना मास पर यूनिट लेंथ ज्यादा, उतनी स्पीड ऑफ ट्रांसवर्स वेव कम. ठीक है, मतलब तुम अगर थिक स्ट्रिंग को प्लग करोगे तो जो स्पीड ऑफ ट्रांसवर्स वेव बनेगी दैट विल बी लेस, बट इफ यू प्लग अ थिन स्ट्रिंग वेयर मास पर यूनिट लेंथ इज स्मॉल, द स्पीड ऑफ ट्रांसवर्स वेव विल बी हायर. If the string is loose, the speed of transverse wave will be less. If the string is tight, the speed of transverse wave will be more. There is no numerical based on this formula. Nothing. There are no questions which are asked on the base of on this topic. So please do not worry about that. That's why I'm telling you, I'm explaining, but there are many things which are just given to you. ठीक है, I will tell you this is important, remember, then you have to remember that. Okay, this is important. As I told you, I will tell you, I'm telling you right now, this is very important. The difference between sound waves and electromagnetic waves. Electromagnetic waves इससे पहले वाला चैप्टर था, स्पेक्ट्रम, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम. इलेक्ट्रोमैग्नेटिक वेव्स में लाइट आता है, विजिबल लाइट, फिर यूवी रेज, यूवी रेज के पहले कौन सा रेज आता है? गैमा रेज, फिर इंफ्रारेड रेज, रेडियो वेव्स, माइक्रोवेव्स, ये सब इन यूवी इलेक्ट्रोमैग्नेटिक वेव्स, और ये सब की कुछ ना कुछ सिमिलर कैरेक्टरिस्टिक्स है यूवी इंफ्रा इलेक्ट्रोमैग्नेटिक वेव्स की. बट साउंड विच ऑल्सो travels in the form of waves has altogether different set of properties than these electromagnetic waves. So what is the difference? यहाँ पे डिफरेंस दिए हुए हैं तुम्हें, डायरेक्टली ये रीड करो. वो पैराग्राफ रीड करने की कोई जरूरत नहीं है, सब कुछ यहाँ पे दिया हुआ है, डिफरेंस बना के दिया हुआ है। इसको लर्न करोगे तो आंसर लिख पाओगे, याद भी रहेगा। सो what are the differences? Light waves are electromagnetic waves. Sound waves are mechanical waves. Mechanical क्यों बोला गया है इसको? Because they require material medium for their propagation. Light waves can travel in vacuum. Sound waves cannot travel in vacuum. They require a material medium for their propagation. The speed of light waves is very high, 3 times 10 to the power 8 meter per second. The speed of sound waves is low, 330 meter per second. The wavelength of light waves, visible light waves, is very small, of the order 10 raised to minus 6 meter. The wavelength of sound waves is in the range of 10 raised to minus 2 to 10 meter. Wavelength में भी फर्क है. These waves are transverse. These means light waves, electromagnetic waves. They are transverse by nature. They are never longitudinal, always transverse. But sound waves are longitudinal in air. In air and inside any liquid. On the surface of liquid and in solid, they will be transverse. Okay, so these distinctions between light and sound waves or electromagnetic waves and sound waves are very important. You need to remember them. Okay, let us talk about reflection of sound waves. Since, of course, we know that reflection is a phenomena which proves that a particular wave is made up of particles, is created by the oscillations or vibrations of the particles. Okay? Can electromagnetic waves get reflected? What do you say? Hmm? You don't know, or you saying you don't know? Can you give me one example of electromagnetic wave? Give me one example which you can see. Is light an electromagnetic wave? Yes. Does light get reflected? So why didn't you say? Why did you say you don't? You know, electromagnetic waves, they do get reflected. Means we can say that electromagnetic waves are also made up of particles. In fact, the waves have dual nature, electromagnetic waves. They are considered as waves also and particles also. मतलब dual nature है उनके पास. Let's not get into that because we are studying sound. Sound, since it is a purely mechanical wave, so it has to get reflected. Sound do get reflected. How you can hear is the example of reflection of sound. The sound which is coming out of my mouth is getting reflected from all the hard surfaces around you and getting reaching to your ears. So that's a simple example of reflection of sound. Sound do get reflected. Reflection of sound is not a big deal. Okay? But in certain circumstances, reflection of sound results into multiple sounds overlapping each other. Here also there is this kind of effect because the high ceiling, okay, and lack of cushion. जहाँ पे ज्यादा कुशंस और कारपेट्स और रग्स और सोफा और फर्नीचर होता है वहां पे साउंड एब्जॉर्ब हो जाता है. इट डज नॉट गेट रिफ्लेक्टेड मल्टीपल टाइम्स, डज नॉट ओवरलैप विथ ईच अदर द साउंड वेव्स, and that's why you hear clear sound without any overlapping effect. That overlapping effect is known as reverberation. Reverberation, इसको शॉर्ट में रिवर्ब बोलते हैं. रिवर्ब, ये रिवर्बरेशन तुम्हें बहुत सारे जगह पे एक्सपीरियंस होगा. You know, when you move into a new house, the house is empty. When you speak in that kind of house, you hear, तुम्हें ऐसा लगता है कि तुम्हारी आवाज गूंज रही है. When you go into a big hall which is empty, you feel the sound is repeating itself. There is no echo, but the sound का जो गूंजना होता है ना, that is reverberation. That is multiple reflections of sound which end up overlapping with each other, and you hear this prolonged sound after the sound has stopped. और ये सेम चीज होती है बाथरूम में भी, और इसलिए बहुत लोग बाथरूम सिंगर्स बन जाते हैं. आई एम नॉट जोकिंग. Bathroom singers is not the term which is coined by me. It is actually a thing. Do you know who is anybody who is bathroom singer? You are a bathroom singer. I thought singer. See, if you are a bathroom singer, I don't mind. Some people are bathroom singers, you know that, but they are not actual real singers, because in bathroom, due to reverberation of sound, the sound of the music or the voice or whatever the person has, it actually sounds good. बट उसको अगर बाहर निकल के गाने बोलो तो नहीं सुन सकते, तो वो बेसुरा आदमी है. बट बाथरूम सिंगर बहुत अच्छा है. तुम्हारे घर पे शायद तुम्हारी फैमिली में कोई बाथरूम सिंगर हो सकता है. ठीक है, अप्रिशिएट देम, एनकरेज देम, और बाहर निकलने के बाद उनको बोलो कि प्लीज गाना मत गाओ, बाथरूम में जाओ गाना गाना. सो दैट इज ऑल्सो एन एग्जाम्पल ऑफ रिफ्लेक्शन ऑफ साउंड, रिवर्बरेशन. ठीक है. The second example of reflection of sound is distinct reflection, that is known as echo, not echo, echo. Echo में overlapping नहीं होता है. This is distinct repetition. After reflection. Distinct repetition of sound after reflection is known as echo. Have you ever experienced echo? कहाँ पे? Sorry? Okay. So you mean echo point? हर हिल स्टेशन पे echo point होता है. You know that? It's a sad place. What is echo? Can you define echo?
Sound heard multiple times after reflection from a certain distance.
A sound heard after the original sound has been ceased. जब ओरिजिनल साउंड खत्म हो जाता है और फिर वही साउंड जब रिपीट होके हमें सुनाई देता है. The sound heard after the original sound has ceased is known as echo. Echo में यही होता है. Once you say whatever you want to say, hello or hi or hey or whatever, once you stop saying that, you hear the same thing again. So क्या हुआ इसमें? The sound waves they went a certain distance, they struck a surface, and then they got reflected back, and then you could hear the same reflected sound. ठीक है, तो ये जो फिनोमेना है दैट इज एको. एको का डेफिनेशन दिया है तुम्हारी बुक में. On, I don't know, the page number might have changed, but still I can show you and you can. The sound heard after reflection from a distant obstacle such as cliff, hillside, wall of a building, edge of a forest, etc., after the original sound has ceased is called an echo. ये इंपॉर्टेंट है, ये डेफिनेशन तुम्हें लर्न करनी पड़ेगी बिकॉज तुम्हें एज इट इज लिखनी है. द साउंड हर्ड आफ्टर रिफ्लेक्शन फ्रॉम a distant obstacle such as a cliff, hillside, wall of a building, edge of a forest, etc., after the original sound has ceased is called an echo. What if the original sound and the echo overlaps? Is it still an echo? It is called as a reverberation. Exactly. So what effect you can hear right now, or maybe in bathroom or a big hall, that's not an echo. That is reverberation. You must be able to distinguish between these two practically. कि यहाँ पे echo नहीं है. If someone says यहाँ पे बहुत echo है, echo नहीं है, वो reverb है. Echo कहाँ पे होता है? It takes a long distance for the sound to come back to you, and you hear it after the original sound has stopped, ceased. That is an echo. ठीक है? The reflected sound, if heard along with the original sound, is not the echo. Only the sound heard after the original sound has ceased is called echo. That means both the sounds, the original and the reflected sounds, they will be distinctly separate from the original sound, from each other. ठीक है? अब कुछ इंटरेस्टिंग चीज है. Okay. For understanding echo, you should understand one very important thing, that is persistence of sound in our ears. हम कोई भी चीज सुनते हैं ना, तो हमारे कानों में वो 0.1 सेकेंड के लिए लास्ट करती है. दैट साउंड लास्ट्स इन आवर ईयर टिल 0.1 सेकेंड. So the persistence of sound in our ears has a limit of 0.1 second. It has a limit of 0.1 second. इसका मतलब क्या है? If you hear two sounds within a gap of 0.1 second, they will overlap with each other, and you will not be able to distinguish between those two sounds because they overlap with each other, because the gap between them is less than 0.1 second. If you hear two sounds in between whose the gap is little bit more than 0.1 second, वो दोनों sound तुम्हें अलग सुनाई देंगे. Suppose in a classroom there are many students and they all start talking together, and that happens. You have heard this thing so many times in your classrooms. जब सब बच्चे साथ में बात करते हैं, कुछ समझ में आता है क्या? Are you able to understand anything? No. If you want to really experience this, वो शो देख लेना, पूछता है भारत, अर्नब गोस्वामी. Everybody talks together. You can't understand anything. क्या बात कर रहे हैं? Because the sounds are overlapping. There is no gap between two words, and the words mix with each other. The sounds of the word mix with each other. You can't understand anything. That means तुम्हारे कानों का एक लिमिट है. कि दो साउंड के बीच में 0.1 सेकंड का गैप होना ही चाहिए, तभी वो दो साउंड समझ में आएंगे हमें अलग अलग, नहीं तो वो मिक्स हो जाएंगे एंड देन विल लूज द मीनिंग। ठीक है। एको में कंडीशन क्या है? व्हाट इज द कंडीशन फॉर हियरिंग एको? नहीं, कंडीशन ये है कि दोनों साउंड डिस्टिंक्ट होने चाहिए। 17 मीटर के मैं आता हूं, मैं वो टेक्निकल है, वो छोड़ दो। एको का मेन कंडीशन क्या है? द ओरिजिनल साउंड एंड द रिफ्लेक्टेड साउंड मस्ट हैव अ गैप ऑफ 0.1 सेकंड बिटवीन देम। Only then you will be able to hear the repeated or reflected sound distinctly, separately from the original sound. और वो होने के लिए ये टाइम 0.1 सेकेंड उसका गैप क्रिएट करना है। ठीक है। अच्छा, अब देखो, बहुत ही सिंपल है, इसको हम लोग कैसे अंडरस्टैंड समझेंगे वो देख लो। सो सपोज वी हैव a place where speed of sound is, let's say, 340 meter per second. ठीक है। द टाइम गैप विच आई वॉन्ट टू क्रिएट इज 0.1 सेकेंड। ठीक है। स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम, यू नो दिस फॉर्मूला राइट? सो डिस्टेंस is equal to speed into time. Speed is 340, time is 0.1, so the distance become 34 meters. How much is the distance? 34 meter. Means the sound should travel a total of 34 meter distance in order to be audible after 0.1 second. If it travels lesser distance, then it will be audible after reflection within 0.1 second. You understand? Here I have taken one assumption that the speed of sound in air is 340 meter per second. The speed of sound may be different at different places. हो सकता है स्पीड ऑफ साउंड 320 है या 330 है, 325 है, कुछ भी हो सकता है। सो स्पीड ऑफ साउंड का एक मैंने एवरेज दिया है कि 340 मीटर पर सेकेंड है। सो मुझे ये मैक्सिमम डिस्टेंस मिला, दैट इज 34 मीटर। टोटल डिस्टेंस द साउंड मस्ट ट्रैवल to be able to heard distinctly after reflection is 34 meters. इसका मतलब ये है कि अगर एक इंडिविजुअल यहां पे खड़ा है, ठीक है, और यहां पे एक वॉल है और यहां से ये कुछ बोल रहा है, चिल्ला रहा है, साउंड वेव्स प्रोड्यूस कर रहा है जिसकी इंटेंसिटी मजबूत है। ठीक है। सो दीज साउंड वेव्स विल ट्रैवल टुवर्ड्स द वॉल, दे विल गेट रिफ्लेक्टेड फ्रॉम द वॉल। वॉल इज अ हार्ड ह्यूज फ्लैट सरफेस, तो डेफिनेटली वहां से रिफ्लेक्शन इजी होगा। ठीक है। रिफ्लेक्ट करके साउंड वेव्स वापस आगे आके इसको सुनाई देगी। लेकिन हमें क्या चाहिए? हमें चाहिए कि ये आदमी को एको सुनाई देना चाहिए। रिफ्लेक्शन, एको क्या है? डिस्टिंक्ट रिपीटेड और रिफ्लेक्टेड साउंड। इसके लिए टोटल जो डिस्टेंस साउंड ट्रैवल करेगा वो 34 मीटर होना चाहिए। टोटल डिस्टेंस 34 मीटर होने चाहिए, होने के लिए ये आदमी और ये वॉल के बीच का जो डिस्टेंस है दैट शुड बी 17 मीटर। तब साउंड यहां से यहां जाएगा 17 मीटर, रिफ्लेक्ट होके वापस आएगा 17 मीटर और उसको सुनाई देगा एग्जैक्टली 0.1 सेकेंड के बाद, और उसको समझ में आएगा कि ये एको। The original sound and the reflected sound will not overlap in this case. समझ में आया? So what according to you are two conditions for a sound to be heard distinctly after its reflection? What are the two conditions I'm asking?
The distance should be 7.
The distance between the person or the object producing sound and the reflecting surface must be at least minimum at least 17 मीटर। 17 से ज्यादा है तो प्रॉब्लम है क्या? नहीं, कोई प्रॉब्लम नहीं है, ज्यादा हो सकता है, कम होगा तो नहीं सुनाई देगा। If the distance is less than 17 meter, then the chances of echo being heard distinctly will be less. ठीक है। तो 17 मीटर शुड बी द मिनिमम डिस्टेंस। इसलिए तुम जब एको पॉइंट पे जाते हो हिल स्टेशंस पे, तो वहां पे सामने क्लिफ होती है विच इज वेरी फार, मे बी 200 मीटर, 500 मीटर्स, ठीक है। सो एको तुम्हें 4-5 सेकंड के बाद सुनाई देता है, एंड दैट इज डिस्टिंक्ट। ओरिजिनल साउंड तो कब का खत्म हो गया, एको तब सुनाई देता है, दैट इज रियली डिस्टिंक्ट। So this is the minimum distance between the object or the person producing sound and the reflecting surface, ठीक है। अच्छा, दूसरी बात, there should not be any obstacle between the reflecting surface and the person producing the sound, है कि नहीं। बीच में कोई obstacle होगा तो reverberation हो जाएंगे, क्योंकि वहां से भी reflect होगा sound, और फिर वो mix हो जाएगा original sound और reflected sound के साथ, so there can be disturbances, you won't be able to hear the echo clearly or distinctly. Third thing, the reflecting surface should be huge, should be large, should be flat, large, huge surface, so that you can also say hard surface, so that the reflections are very powerful. नहीं तो क्या होगा पता है, अगर ये सॉफ्ट सरफेस है, तुमने देखा है मूवी हॉल्स में, मूवी हॉल्स के जैसे ही तुम अंदर जाते हो ना, उसके डोर पे ही फोम लगा होता है, हैव यू सीन दैट। मूवी हॉल के डोर पे ही फोम लगा होता है, फोम वाले डोर होते हैं, ह्यूज डोर्स, थिक डोर्स। और वॉल्स देखिए मूवी हॉल्स की, कारपेटेड वॉल्स होती है, फ्लोर देखा है फुल्ली कारपेटेड, सीट्स पे कुशन, और जो वॉल्स होती है उस पे बड़े बड़े कर्टन्स होते हैं। why they put all those things, why make so much of, so they want to minimize the effect of echo and reverberation both, because there's going to be a lot of sound for sure, it's a huge hall, 17 मीटर से बड़ा डिस्टेंस हो सकता है किसी एक वॉल के, दो वॉल के बीच में, एंड मे बी अगर एक वॉल पे स्पीकर है तो एको हो सकता है, और एको से कंफ्यूजन होगा, रिवर्बरेशन से ओवरलैप हो जाएंगे साउंड, साउंड रिपीट होके ओवरलैप होके कंफ्यूजन क्रिएट करेंगे, यू वोंट बी एबल टू हियर एनीथिंग क्लियरली। फॉर दैट दे पुट द साउंड एब्जॉर्बिंग मटीरियल्स, और जहाँ पे साउंड रिकॉर्डिंग स्टूडियोज होता है वहां भी लगाते हैं, सो दैट द साउंड डज नॉट लीक आउटसाइड, ठीक है। सो ये साउंड एब्जॉर्बिंग मटेरियल का अच्छा एप्लीकेशन है। Okay, so this is all about echo. अच्छा, tell me one thing, ये तो हो गया रिफ्लेक्शन ऑफ साउंड, रिफ्लेक्शन ऑफ लाइट भी, इलेक्ट्रोमैग्नेटिक वेव्स भी पॉसिबल है। डू अल्ट्रासोनिक साउंड्स रिफ्लेक्ट? They do reflect, they are also sounds, only their frequency is high, they also reflect. Do infrasonics reflect? Yes, they also reflect. Every kind of wave shows reflection, रिफ्लेक्शन सब में होता है। Okay, so I'll just go through this thing.
सर डिस्टेंस एक आदमी और बॉल के बीच में 17 मीटर है, तो हम लोग जो वॉइस प्रोड्यूस कर रहे हैं उसकी भी तो स्पीड होनी चाहिए।
स्पीड तो वही होगी 340 मीटर पर सेकेंड, लेकिन उसका इंटेंसिटी बहुत स्ट्रांग होना चाहिए। इंटेंसिटी का मतलब क्या है, इंटेंसिटी किससे क्रिएट होती है, एम्पलीट्यूड से। एम्पलीट्यूड ज्यादा मतलब लाउड होना चाहिए साउंड, लाउड साउंड में ज्यादा एनर्जी होती है, ज्यादा एनर्जी मतलब ज्यादा इंटेंसिटी, मोर इंटेंसिटी मीन्स इट कैन गो अप टू long distance and can be heard. You want to call your friend who is standing very far away, what do? You shout. Shout means loud sound means more intensity, इंटेंसिटी ज्यादा होनी चाहिए, ठीक है। स्पीड तो 340 मीटर पर सेकेंड ही है साउंड की, बट देर आर फीबल साउंड्स विच डाई आउट बिफोर reaching a certain considerable distance, and then there are loud sounds which reach a distance because of the high intensity. So to hear echo distinctly, the following three conditions must be satisfied. Let's see what are the three conditions जो textbook बता रही है। The minimum distance between the source of sound or the observer and the reflector in the air must be 17 meter. It is different in different medium depending upon the speed of sound in that medium. For example, inside C क्या होना चाहिए distance देखो, जहाँ पे speed of sound 1400 मीटर पर सेकेंड है. So जो distance है that should be 70 meter. 70. To hear the sound or to receive that sound signal distinctly after the original sound has ceased, the distance between the sound producing body and the reflecting surface must be 70 meter. Acha. Size of the reflector must be large enough as compared to the wavelength of the sound wave. Huge cliff, huge building, huge wall, edge of the forest. These are all massive things. So they will act as a good reflector. The intensity of the sound should be such that the reflected sound reaching the ear is sufficiently intense to be audible. तुम एको पॉइंट पे जाके धीरे धीरे बात करोगे और बोलोगे मेरे को एको क्यों नहीं सुनाई दे रहा है, फिजिक्स फेल हो गया है, आई डोंट बिलीव इन फिजिक्स, गलत. ओके, you can also determine the speed of sound by the method of echo. You can determine the speed of sound. You want to find the speed of, you are just assuming 340 meter per second, right? If you want to determine the speed of sound, what you have to do is you have to find a place where there is a huge reflector, a wall or a cliff, and you have to stand in front of it at a known distance. मतलब distance तुम्हें पता होना चाहिए, and should be fairly large distance. So let's say I found a wall, huge wall, and I'm standing at a distance of 50 meter from the wall. I know the distance, right? Now I will produce a sound. I will have a stopwatch in my hand. I will, as soon as I produce the sound, I will start the stopwatch, and then I will wait for the repetition or the reflection of the sound to be heard distinctly. As soon as I hear the repetition, I will stop the stopwatch. Then I will note the time interval. I have the distance between me and the reflecting surface. I will double the distance because sound has first gone and then come back. So double the distance divided by the time will give me the speed of sound. So easy. Why are echoes very useful? Echoes are not just used by tourists to amuse themselves on echo points in Lonavala. They have some uses, actual uses. They can travel undeviated through a long distance. This is the use of ultrasonic sounds in the process of echo. What happens when you want to throw the ultrasonic sounds at a certain distance and receive them after some time so as to get some information, maybe depth of the sea, maybe picture of an organ inside the body, right? It's all based on reflection. So they can travel undeviated through a long distance, ultrasonic waves. They can be confined into a narrow beam. They are not easily absorbed in a medium. These three characteristics make them perfect for the applications which we are going to study now. Audible sound waves, they do not possess these properties. Audible sound waves cannot be, they do not travel in a narrow beam through a long distance. They cannot be confined to a narrow beam. They are easily absorbed. The normal sounds are easily absorbed. Ultrasonic sounds are not easily absorbed, so that they can penetrate into a medium and they can actually travel a long distance. Okay. Both the sound waves, ultrasonic as well as your normal audible sound, they have same speed. There is no difference in speed. The difference is there in their energy. The energy possessed by ultrasonic sounds are huge, very large energy, and that's why they can penetrate. We have already discussed these yesterday. Uses of echoes by bats, dolphins, and fishermen. They use ultrasonic sound, echoes of ultrasonic sounds, to detect their enemy or detect their prey or to move through a medium and so on. Fishermen also use ultrasonic sounds. They send the pulses into the sea, and when they can find the depth of the sea. When suddenly the depth of the sea becomes less, that means there is some obstacle between the seabed and the ship, the surface of water. And that obstacle may be a sunken ship, it may be a shoal of fish. Shoal of fish means group of fish. So if they want to catch the fishes, they can easily catch. They can locate them easily. Sonar, everybody knows sonar. Sound, navigation, and ranging. SO means sound, N navigation, and ranging. Sonar. So it is used for finding the depth of the sea. There is a similar term like sonar. There is another term which is known as radar. Sonar is sound navigation and ranging. Radar is radio detection and ranging. It also uses echo method, but with radio waves and microwaves, not with ultrasonic sounds. Because ultrasonic sounds cannot travel in space. Radio waves or radar, it works from space. It travels. The radio waves can also travel in space. So that is radar. In medical field, echoes are used uh, to find the image of human organs, and this method is ultrasonography and echocardiography for getting the picture of the heart. Okay, so this was the first part of the chapter. Quite simple. I'm going to do some examples for you. Um, Before that, I'll just mark some homework for you guys. Question number 1, 2. Just check if the questions are same. 4, 5, 6, 7, 8. Yes. Okay. All these you have to just mark with the proper number. Here the numbers are same, right? Only the sixth one is the seventh one in your book. Seventh is eighth and eighth is the ninth. Okay. Thirteenth question. Okay, that is your 14th. Okay, that's it. Chalo, let's do the numericals. The wavelength of waves produced on the surface of water is 20 centimeter. Lambda. 20 centimeter. Let's convert this 20 centimeter into meters. So this will be 0.2 meter, correct? If the wave velocity is 24 meter per second, v, 24 meters per second, calculate the number of waves produced in 1 second. What do you mean by number of waves? Yes. And the time in which one wave is produced. Time period. Time taken for one wave. है ना? Can anyone tell me the formula?
V equals to F lambda.
V is equal to F lambda. Yes, that is the first formula. So 24 is equal to F times 0.2. So F is equal to 24 divided by 0.2, which is 120 hertz, correct? T is 1 by F, 1 by 120. Please find the answer in seconds, in points. कितना आ रहा है? Okay, but it cannot be 8.3. It should be 0. Yeah. So into 10 raised to minus something also you can write. You can write it in scientific form. ठीक है, you calculate.
0.0005.
So answer is 8.3 times 10 raised to minus 3. 8.3 times 10 raised to minus 3. ठीक है? If you do not know this calculation, it's simple. I'll show you here if you do not know. ठीक है, अपने को डिवाइड करना है 1 को 120 से. तो मैं यहाँ पे 0 पॉइंट, ठीक है, जैसे ही मैंने 0 लिया यहाँ पे मैं एक 0 डाल सकता हूँ. ठीक है, बट अभी भी ये डिवाइड नहीं होगा. सो और एक 0 लेना पड़ेगा. आई कैन पुट अ 0 ओवर हियर. अभी भी डिवाइड नहीं होगा. और एक 0 लेना पड़ेगा और एक 0 एंड देन आई कैन डिवाइड. सो 8 8 जा 90 960 है ना. सो ये हो जाएगा 40. ठीक है, अब मैं 0 ले सकता हूँ, कोई प्रॉब्लम नहीं है. 3 जा 360, यहाँ पे आएगा 40 एंड ये चलता जाएगा 33333. सो 0.0083, 0.0083 can be written as 8.3 times 10 to the power minus 3. 8.3 times 10 to the power minus 3 seconds. ठीक है, सिंपल. डू नॉट लीव योर आंसर इन फ्रैक्शंस. ओके, उसको साइंटिफिक फॉर्म में डेसिमल्स में कन्वर्ट करना है तो कैसे भी. कैन एवरीवन हियर मी क्लियरली? Okay, fourth question. A man standing 25 meter away from a wall produces a sound and receives the reflected sound. Okay, so the distance is 25 meter. No, not lambda. This is echo ka question. So you will take D. Okay. Acha, see, this is one way distance. We cannot take one way distance. We usually take two way distance. So 2D is equal to 50 meter. ठीक है. एक आदमी 25 मीटर दूर खड़ा है एक वॉल से. Calculate the time after which he receives the reflected sound if the speed of sound in air is 350 meter per second. So the speed of sound is 350 meters per second. Speed is equal to distance upon time. Distance की जगह मैंने 2D लिया है जानबूझ के because it's going to be reflected and come back through the same distance. I have to find the time. Time is equal to 2D by V. So time is equal to 50 by 350. That is 1 by 7 seconds. Point में निकालो please. 1 by 7. 0.143. Sure? 0.143 seconds. Can you tell me whether he'll be able to hear echo or not? Means whether he'll be able to hear the sound distinctly. Why? The time gap is greater than 0.1 second. Okay, let's check. 0.143 seconds, yes. Okay, try question number 5 yourself. A radar sends a signal to an aeroplane at a distance 45 kilometer away. So what is this? This is the one-way distance. With a speed of 3 times 10 to the power 8 meter per second. This is the speed of the radio wave. Doesn't matter which chapter we are doing, we know about waves, we know about echo, so this question can be solved. After how much time is the signal received back after reflecting from the aeroplane? So you have to take the distance as 90 kilometer, convert it into meter, take the speed as 3 times 10 to the power 8 meter per second and find the time. Come on. Easy this one. Yes, you have to convert distance of 90 kilometer into meters and then calculate. Okay, कोई भी doubt है, I will show you, don't worry. So the distance is 90 kilometer, which is 90 times 10 to the power 3 meter. The speed is 3 times 10 to the power 8 meter per second. I have to find the time. Okay, this is the total distance. So time is equal to distance upon speed, that is 9 times 10 to the power 4 upon,
उधर 90 किलोमीटर है बट हमारे वहाँ पे 300 किलोमीटर है।
कोई बात नहीं, हम इसके हिसाब से करते हैं। 3 times 10 to the power 8, 3 3s are, so the time will be 3 times 10 to the power minus 8 seconds. Yeah, minus 4 seconds, I'm sorry. Minus 4 seconds, silly mistake. तुम्हारी बुक में अगर 300 है तो उस हिसाब से वैल्यूज लेनी है, कोई प्रॉब्लम नहीं, मेथड सेम रहेगी। Okay, next question number 8. A pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires a gun simultaneously. He hears echo from the cliff after 8 vibrations of pendulum. एक बात समझो, पेंडुलम की फ्रीक्वेंसी 5 वाइब्रेशंस पर सेकेंड है, मतलब in 1 second it makes 5 vibrations, और उसको एको कब सुनाई देता है? 8 वाइब्रेशंस के बाद। तो 8 वाइब्रेशंस को कितना टाइम लगेगा? यू कैन फाइंड इट विथ यूनिटरी मेथड। 1 सेकेंड में 5 वाइब्रेशन होते हैं, तो कितने सेकेंड्स में 8 वाइब्रेशन होंगे? सो इट विल बी 8 by 5 seconds. This is the time. This is the time after which he hears the echo. समझ में आया तुमको? A pendulum has a frequency of 5 vibrations per second. An observer starts a pendulum and fires a gun simultaneously. He hears echo from the cliff after 8 vibrations of the pendulum. If velocity of the sound v दिया है 340 मीटर पर सेकेंड, ठीक है, फाइंड द डिस्टेंस बिटवीन द क्लिफ एंड द ऑब्जर्वर। तुम्हें डी ढूंढना है। ये जो भी तुम्हें डी मिलेगा उसको 2 से डिवाइड कर देना, सो यू विल गेट द एक्चुअल डिस्टेंस। वो पेंडुलम वाला सिर्फ कंफ्यूज करने के लिए दिया है। पेंडुलम की फ्रीक्वेंसी से तुम्हें ये पता चलेगा कि 1 सेकेंड में 5 वाइब्रेशन होता है, एंड देन यू विल गेट द टोटल टाइम फॉर 8 वाइब्रेशंस। Directly? Directly? No, means the answer is 272. No. No, you see, he hears echo from the cliff. So sound must have traveled from the gun to the cliff. That's what I'm asking. What is the distance? Yeah, so exactly. So this is the total distance traveled by the sound. Okay, you have to divide it by 2 to get the distance between the cliff and the gun, not the person. So this is nothing but 2D. यहाँ पे तुम 2D लिखोगे ना फॉर्मूला में तो भी अच्छा है. So therefore D is equal to 272 meter. Okay, this is a good one. Good question. A man fires a gun and hears its echo after 5 seconds. Okay. The man then moves 310 meter towards the hill and fires the gun again. This time if he hears the echo after 3 seconds, calculate the speed of sound. Please try to understand what they are saying. Okay, I will explain the whole thing with the help of a diagram. Okay, now understand. This is position A, this is position B. First, the man is standing at position A. Okay, and he fires a gun and hears the echo after 5 seconds. So here at position A, T1 is how much? 5 seconds. Then he moves towards the cliff. How much? By how much meters? How much distance? Do you have the same question in your book? 300. Do you don't have this question in your book? Okay, good. 310 meter. He moves towards the cliff by a distance of 310 meter and reaches position B. And then again he fires the gun and hears the echo after 3 seconds. We have to find the speed of sound. Okay, let the distance between him and the cliff, original distance, be x meters. From position A, the cliff was how far? X meters far. Can you tell me what will be the distance of the man from the cliff from position B?
46 minus 300.
Right? You have the distance and you have the time. Speed का formula क्या है? Distance upon time. Yes, 2d upon t. Because the time is about the echo. That means the distance should be double. Okay. Now see how I'm formulating the equation over here. In the first case, the speed of the sound will be 2d, that is 2x upon 5. Do you agree? In the first case, 2x upon 5. 2 into the distance divided by the total time. In the second case, it will be 2 bracket x minus 310 by 3. 3 क्यों लिया? क्योंकि अब टाइम कम लग रहा है, क्योंकि वो नजदीक चला गया क्लिफ के, है ना? तो 2d/t दोनों का जो फॉर्मेट है ना, इफ यू सी देम वेरी क्लोजली, इट इज 2d/t which is equal to 2d/t. कैन यू टेल मी व्हाई हैव आई इक्वेटेड देम? मैंने इक्वेट क्यों किया? स्पीड ऑफ साउंड इज सेम इन बोथ द केसेस. स्पीड ऑफ साउंड थोड़ी चेंज होगी, वो तो वहीं पे खड़ा है उसी पोजीशन पे. So you just have to solve this equation whichever you get from here and find the value of x first and then find the value of speed of sound. Substitute x in any one of LHS or RHS and get the speed of sound. Come on. x की वैल्यू 310 है, नॉट पॉसिबल.
775.
आर यू गेटिंग? आगे सॉल्व करो. स्पीड ऑफ साउंड इज 310. अनयूजुअल, बट हो सकता.
सर मेरे को
ठीक है, फर्स्ट पार्ट तो हो गया चैप्टर.